Let me do a somewhat tricky example here. And it's really only tricky because of the voltage source. And you'll notice that all these circuits look kind of similar. They've all got resistor, capacitor, inductor, voltage source. Some of them have a switch to them. And once you've solved them, there's only a finite number of different configurations. So once you've seen them all, they all just fall apart. Find your current. Here's your current. Yeah, find that current. How'd you go about it, John?
I'm going to first draw it for time is less than 0, right?
That's it. So you're going to find your initial conditions. And to find your initial conditions, you're going to draw it for time less than 0. And John, what are the two things you're going to find in time less than 0?
I'm going to find V sub C and I sub L.
That's it, no matter what you're asked. Now, we're going to have to define those variables. So here is your I sub L, and look, it's the same as I, so we've already defined that. That's easy. Does the plus go on the top or the bottom, John, if we're going to use our V equals L didt rule? We want to define the voltage across this guy too. Do we want to put the plus on the top or the bottom?
The plus should go on the top.
I think I heard you say the plus on the top, but I think you're unsure.
I am unsure, and I think it is the plus on the top.
Okay, let's figure out what it is, just as in a little aside on passive sign convention, so that there's no guessing. If you've got a resistor, the passive components that we've talked about are resistors, capacitors, and inductors. And we've learned relationships between V and I for each of them. But in order for those rules to be true, I did capital for resistor only because we use capital letters when things don't change. It's true for resistor whether or not it changes. If we're going to define a current and voltage, though, we need to define the direction of current relative to voltage. And so the passive sign convention says that current always exits at lower pressure than it enters. Just like if you were thinking again about people going through a doorway, they're going to have a higher pressure where they enter the doorway, and then once they get through the doorway, it'll be a lower pressure. So if we define our current like this, we have to define our voltage like this if we want this to be true. And there's nothing magical about the direction of the arrow. We could define the arrow in the opposite direction, but what matters is that it enters more positive and it exits more negative. It enters more positive and it exits more negative, than the current has to be in this direction. So you can define the current to be in any direction you want, but once you define the direction of the current, you have also defined the voltage polarity if you're going to use the passive sign convention. And you have to use the sign convention for Ohm's law or these two rules to be true. Thumbs up? Excellent. So now, armed with that, can we get a definite answer on about how to define our V sub L?
Yeah, so it's going to be positive on top, negative on bottom.
Definitely. Good. Okay. So we've gotten that, and let's see. You said I. We still need to find our V sub C. So again, we could define the current through the capacitor in either way, but since we've already defined a current, let's use this current to be both I sub L and I sub C, and then it enters more positive and it exits more negative, and that's going to be our V sub C. So now we've defined everything that we need to. I'm going to just get rid of this extra current there, since we really only need the one current that we initially defined. That's the same as the current through the capacitor and the inductor. And let's draw it. So for time less than 0, Jonathan, what does the voltage source look like?
It's just a 20-volt source.
Yes, that's right. And that's something a lot of people don't see, that since you've got this minus T, that's going to look like a 20 volt source for time less than 0 and a short for time greater than 0.
I was thinking that if it was like greater than 0, then you'd have the -1 for t, so it'd make it -20. Is that correct?
Yeah, that's right. Or alternatively, just throw in some numbers. U always does its thing whenever its argument is 0. So you can see it's going to switch at t equals 0. You're just not sure if it's going to switch up or down. So throw in a value, throw in t equals 1. And then and for t equals 1, you can see it's u of -1. You know that's 0. And so therefore u of negative values will have to be the opposite, which is +1. Either way. Oops, and I started to draw too much. Jonathan, continuing with you, what does that capacitor become for time less than 0?
It would be open.
It'll be an open. And just in case there's any doubt about what I just did, I'm just going to draw what u of -t looks like. So it's that flipped version of u of +t. Okay, so this is an open. We've got our VC, which we need to find. We've got our inductor, which is going to be a short since we're in DC steady state. And we need to find that I. And so, Connor, tell me what V sub C is, just by inspection.
V sub C should be 20 volts.
That's it. Positive or negative?
Positive.
Yeah. Positive because the plus on the V sub C is in the same direction as the plus on the 20. And the minus on the V sub C connected through this wire is the same as the minus on this 20. And Connor, just finishing it up, what's I?
I should be 0 amps
Because
it's an open, so there's no loop that current can flow through.
that's it. Because of this open here, can't get any current flow. Okay, good. We've got our first part of our initial conditions. Let's get that part B of the initial conditions, which is what happens at t equals 0 plus. And in this time region, we're looking for two other things. What are they, Philip? What are the two things we want to find for t equals 0 plus for the circuit?
So at 0 plus, we're looking again to find VC and I.
No.
We're looking at, sorry, VC prime and I.
No.
Right, we're looking to find the primes.
That's my question, is what do we want to find? Our overall goal is to find I.
Oh.
You're half right. We do want to find I of 0 plus. But what's our other thing?
So if we're finding I 0 plus, we also don't want to find VC. We don't want to find VC at 0 plus.
No.
Okay.
You want to find I of 0 plus, and you want to find I prime of 0 plus.
Oh,
So,
right.
So at less than 0, no matter what you're asked to find, it's VC and IL. And for time equals 0 plus, that's when you switch over and you say, what am I asked to find? Whatever I'm asked to find, I want to find that value at 0 plus and its derivative. And maybe it's I sub L like it is here, but maybe it's something totally crazy like V sub R or I sub R or I sub C. But whatever it is, you find that and its derivative. So Phil, let's draw it out. What does your voltage source look like?
So your voltage source is just going to be, it's not going to exist. It's going to be a short because time is 0 plus.
That's right. It exists. It's just 0. Yeah.
Okay.
And we got our 5 ohm resistor. And what else do we have?
And then you're going to have VC, now like a voltage source there.
That's it. And is the plus going to be on the left or the right?
On the left side.
That's right, because we originally defined it on the left up at the top, so it stays there. And we said that's going to be 20 volts. How about that inductor? What's that going to be?
So that's going to be a 0 volt source, 0 amp source.
Yeah.
So you write that as an open or?
That's it. We could draw it as a 0 amp source, but it's just simpler to draw it as an open. And now we're going to draw all the rest of the stuff that we didn't draw so far. So here's our I, And here's our V sub L. V sub L. And I think that's everything. Okay. Now,
So I have one question, sir, about this.
yeah,
And it's just that whenever we find I at 0 plus, since we know the properties of I 0 plus and I 0 minus, or is I 0 negative, however you say that, like the time before 0, the time right after 0, since the voltage and the current doesn't necessarily change instantly.
that's
I mean, the
true for
tendency that I've
VC
seen.
and IL. Only for VC and I sub L does the voltage and the current not change instantaneously. Everything else can change instantaneously.
And is that why
But
we have
certainly
to
the
still
derivatives can
evaluate
change
I?
instantaneously.
Okay. So that's why we're still evaluating I, even though it tends to be the same value we found earlier.
Well, in this particular case, because we're looking for I sub L, you're right. Filling it in, it's got to be this. Whoops, it's got to be the same thing as what we found earlier. I is the same as I sub L, so therefore that can't change. But the derivative certainly can change.
Right. So that's my question.
And
I don't know,
what
I
would
guess
happen if I asked instead to find V sub R? V sub R can instantaneously change, not just its derivative, but its actual value can suddenly
Right.
jump. Or
Okay.
I sub C can instantaneously jump.
Okay.
In general, maybe not
I
in
guess
this particular geometry.
It just seems like the trend line has been that whatever we're finding, that value is generally the same at the time before 0, is the same as the time right after 0. But I guess that's just situational. Is that what you're saying?
It depends entirely on the circuit. It really does. So, yeah, like for instance, just as an example, don't write this down, but what would happen if I asked you to find V sub R? And I could have just as well done that instead of I. So I'm going to define V sub R in the reasonable way. What was our first step is to find V sub C and I. What would V sub R be for time greater than 0?
V sub R, would that be negative 20 volts?
No. Take a look at it for 0 plus. Here's our. We didn't define it before, but what is that voltage?
Okay. That's going to be is that going to be 0? Is there going to be no voltage over there? No
That's
voltage
right, because it's shorted out. So in fact, this whole thing is one node. So everything in here is all going to be the same voltage. So it's the same voltage top and bottom. So V sub R is indeed 0. And what was it just before? What was it at 0 minus?
It was what, 20 volts? I believe you said.
It was 20 volts. Yeah. So
Okay.
In general, things can suddenly change.
Okay.
Good question, though. All right, now getting back to this question, we still need to find, we still need to find our I prime of 0 plus. How are we going to get it into the, Dom, how are we going to get it into the world of primes? What are the two equations? Oh, even before that, Dom, tell me, I'm looking at this equation, at this schematic, and it looks unnecessarily complicated. What can I simplify?
Which one are you talking about the T0 plus diagram?
Yeah, exactly. What can I simplify there?
Well, if it's just an open there, then that loop wouldn't have any current flowing through it, so you could get rid of that, right?
Sure. And if I got rid of that, and it's absolutely true that if I get rid of all that stuff, I end up with this. Right?
And then you would do
But what's wrong with that? Why is that a mistake?
well, you need to find your V sub L so that you
You
could
just
find
destroyed all the stuff we want to find. So we don't want to simplify to the right of the circles. We want to simplify
to what?
to the left of the circles. You can simplify any part of the circuit you want to, but you better not simplify away the thing you want to
Well,
find.
if that's 20 volts there and 20 volts at the bottom, then you can get rid of the 5 ohm resistor since it's shorter around the outside.
Right. So right, and a rigorous way of saying what you just did is to say we're going to simplify to the left of those green bars. So this thing is equal to that. And so now we can put our simplified version back in. Maybe what I'm saying is so obvious to everybody that I don't need to say it, but there are going to be some folks who simplify away the thing that they need to find, and I don't want you to do that.
So now you would do I prime is equal to V sub L over L.
Yeah, I'm going to write down the two. You're right. I'm going to write down the two equations that you know. V sub L equals L I prime. And I'm just writing I since there's no I sub C, there's no I sub L. It's just in this thing, L. So Don, what you're saying is that this is the one that's got the I prime in it. So you're going to solve that one for I prime. And you're going to say, and you're saying that that current at 0 plus is equal to 1 over L times V sub L at 0 plus, which is equal to, let's see, what was
Negative
our
80 amps.
for, yeah, what's our V sub L?
Oh, it was negative 20 volts.
Negative
Fine.
20. Yeah, because the signs here are the opposite to the signs over here. So negative 80
Amps
amps
per
per
second.
second. And now we've got our initial conditions. Cool.